I'm Bill Tanner, technical editor with Intelligent CIO, and my guest is Todd Higinbotham, who is the CIO of ZincFive. This Q&A will discuss the application of nickel-zinc systems. Todd, nickel-zinc batteries combine high power density, a water-based chemistry, and inherent safety with no thermal runaway risk. What advantages do these characteristics provide compared with traditional lead acid and lithium-ion technologies in mission-critical environments?
Yeah, so because we are operating in data centers primarily, it's a short duration application, meaning we just back up the data center for about 3 to 5 minutes
Mm.
until diesel gen sets start up. And because of that, the rate of discharge, which is measured in power density, it allows us to have a much smaller battery. And so that smaller battery allows us cost advantages and footprint advantages. And then, of course, with this inherent safety, you can change the installation of the data center regarding everything from permitting to fire suppression, water available for fires, things like that. So it spans across multiple areas.
With more than 90% recyclability and a 25 to 50% lower lifestyle carbon footprint than most conventional battery technologies, nickel zinc is gaining attention for its sustainability profile. Now, how are these attributes influencing infrastructure decisions among data center operators?
Yeah, for a long time they didn't that much. I mean, people gave lip service to these things, but it's
Mm.
becoming more and more serious as you see the growth of battery systems across the world. Things like sustainable supply chain, the carbon footprint of how the battery is made, how much water is used, become bigger issues because you're at much higher volumes. So it's become more critical. And certain regions of the world, like the EU as an example, has
Mm.
growing regulations around battery usage and sustainability through things like the battery passport. So it gives us innate advantages in that area, and that it's built into our chemistry, right? We're not doing something special. It's just from design up. Nickel zinc has inherently a very low carbon footprint, widely available materials, and relatively ease of recycling.
ZincFive has now deployed nearly, 2 gigawatts of nickel zinc systems globally. What lessons from these large scale deployments have shaped the company's approach to innovation and continuous improvement?
Yeah, I was about to say, continuous improvement is the key. This is a very conservative industry,
Mm.
risk adverse. The expectations as far as quality, safety, support of the customer are very high. So as we entered the market, like a lot of new technologies, you're very focused on your product and the advantages your product has and how you can break into the market. As we've gotten broader and wider, it's becoming much more about support. So,
Yeah.
we're shipping batteries to faraway places and making sure the customer is supported, and we can do that. So, we've really looked at that as I'll call it the last year or two of how do we actually take care of the customer completely, and that's been a big lesson for us in this space, and it's really helped us succeed.
ZincFive often describes its technology as delivering immediate power solutions. What does immediate power mean in practice, and why is this capability becoming increasingly important for modern digital infrastructure?
Yeah, it's a great question. So, as coming up with a we'll call it a new old battery. Of course, nickel zinc's been around since the time of Edison, but us bringing it to the market, we had a very distinct take on this technology, which is designed it around power and short duration.
Yeah.
So very focused on applications that are anywhere from minutes down to seconds, and now with AI, milliseconds. So in coming in, both raising money and talking to customers, we had to have a platform to speak from, and other batteries really focus on energy. So battery energy storage systems and things like that, long duration. So we use the term immediate power to talk about this high power, short duration space as a platform for us, because that's all we do. So we're really focused on developing that segment. So that's our strength, and we're really focused on doing that. So Yeah, immediate power solutions. The word solution is overused, but for us, what it means is we're delivering something that can be used. When I started in this space, we had the battery technology, but it was very difficult for the customer to take the raw battery and use it because we
Mm.
have differences of things like voltage and how you charge and things
Yeah,
like that. And we realized we had to wrap around that what we would refer to as quote unquote the solution, which
yeah.
would make it quite easy for the customer to use. So we entered the data center market with what we would call a fully backward compatible product where they could connect it to the current systems that are using lead acid and lithium without any change.
Now, AI workloads are fundamentally changing data center power profiles, shifting from predictable commute loads to sudden high intensity demand spikes. How is this transformation redefining what reliable power infrastructure looks like in the AI era?
Yeah, it's changing everything, really, from the industry I entered, 10 years ago to the
Mm.
industry today. What I would call it is data center industry wasn't really technology focused, it was infrastructure focused. So trying to deploy data centers at volume and get them in the right geographies. And, it's dominated in the US by, real estate companies. That sort of
Yeah,
tells you the
yeah,
technology level, right?
yeah.
It's building and leasing, hardly a technology business. And because of that, suppliers like us trying to break it, it's very difficult because they're just looking for reusable,
Yeah.
reliable technology to use. But with the advent of AI and the description you did of the power, so you have a couple things happening. One is dynamic power loads, where
Mm.
the GPUs use power in an irregular manner, and that's a feature, not a bug. So at the
Mm.
highest throughput of data processing, they're consuming the most power. And as they're sinking, you're seeing this pulsing happening.
Yeah.
And then also their power density, so the amount of power used in a space of actual servers is going up dramatically. And by the way, that was already happening with CPU servers, which is when we came into the market.
Mm.
That's why our high power dense batteries were welcomed because everyone's trying to scale power density. But you have the combination now going forward where that power density is going up 5, 8, 10 times with GPUs in a very short period of time, 3 to 5 years. And you have the dynamic pulse loads. So
Yeah.
it was sort of a little bit sleepy as far as technology has turned into a full-blown technology industry overnight.
Yeah.
Everyone roadmaps. When's the next chip coming out? What are the new architectures? What are the new nodes? It
Mm.
feels very much like my former industry, semiconductor, all of a sudden.
Mm. AI dynamic power events can spike up to 15 times idle loads in milliseconds. What risks do these instantaneous surges create for traditional battery systems that were originally designed for primarily for backup runtime?
Yeah, really, most batteries just are not capable of it. That's not what they were made to do. And if you, read the current press, handling these dynamic loads, people aren't thinking about batteries. They're thinking about things like supercapacitors, which
Mm.
are built to do exactly that. So what you're seeing right now is solutions being oversizing the power, which is call it the big hammer. You build 150 megawatts, but you only deploy servers into 100 megawatt. And so
Yeah.
there's your 50%, no problem. Well, the problem is the cost.
Yeah.
That's a lot of billions of dollars of power infrastructure, but that works. That works. And then supercapacitors, I think, are the next obvious solution going forward, where large banks of supercapacitors can absorb this pulsing. And then we're bringing to the market a battery solution, which can do that very short duration pulsing plus longer duration. And we say longer, I mean, instead of 50 millisecond pulses, we could do up to 5 minute runtime, just like our UPS. So with the same battery, we're not redesigning our battery. We're just redesigning the power electronics. We have the opportunity to offer a combination product. We've already released our first version of that called the BC2 AI, where it is primarily a UPS system, but we've been able to add some capability to limited pulsing. So if the customer has some pulsing, it doesn't void the warranty, it can handle that. But as I described earlier, Bill, the
Yeah.
next 2, 3 generations, that power has to go up a massive, and the power spikes are going to be more
True.
more problematic. So we're designing new products for the shorter duration. So think pulse first, backup second, instead of
Yeah.
backup first, pulse second. Yes.
So delivering extreme bursts of power repeatedly without degradation or safety concerns is technically demanding. How does nickel-zinc chemistry enable this level of responsiveness for AI workloads?
Yeah, well, we it goes back to the fundamentals that I talked to you about. We use the tagline, the power of good chemistry, and it's a bit of a play on words there around power, but it's built into the chemistry. So we designed this platform from the beginning 20 years ago to do high power. So the market came to us. We didn't know about AI dynamic workloads 3 years ago. We certainly didn't know about them 20
Yeah,
years
yeah,
ago. We were designing the battery for things like starting large engines like diesel generators or
yeah,
automotive stop start or very short cranking applications. So the AI workload sort of came to us. It's built into our chemistry. That's what it's good at. And so
okay,
as we started to test against these very short, 50 millisecond, 100 millisecond loads, the batteries are very good at withstanding that, millions of cycles. The battery's hardly discharging and it's built in. Now, one of the comments you made, the batteries do degrade faster than a UPS system because in UPS, the batteries are effectively just sitting and waiting for something bad to happen every day,
yeah,
meaning we're
yeah,
going out. With these dynamic loads, it's being used every day. It can be millions of cycles a month, so they do degrade faster. So it's turning the battery more into a consumable over time. You change them out much faster, but it's okay because now you're on the revenue generating side, power delivery. You're not just a backup system. So the cost of that can be absorbed. And so it depends on how often they use it. So they will degrade faster than UPS for sure because they're really just sitting on the shelf. But it still will work economically.
ZincFive recently introduced the BC2 AI battery cabinet specifically for AI-driven environments. How does this system help operators manage dynamic power loads while also providing reliable backup protection?
Yeah, it's really one of the untold stories right now, which is the transition period. We have had batteries that were sold purely for UPS,
Hmm.
where we've had a problem with the battery. And when we go look at the battery management system, we realize that they have been pulsed by GPUs. They weren't designed, the
Interesting.
system wasn't designed. The reason for that is when these co-location data centers are built, they could take 12 to 18 months to build.
Hmm.
They aren't sure what kind of loads they're going to have when they build it. They're still developing their clients. Now, if it was a single use, single tenant type site, like a big hyperscaler, they would know. But more traditionally, they're leasing that space out to multiple clients. And if the clients bring GPUs and they haven't designed that in,
Yeah,
that creates the problem I just described. The alternate is you build it all in and all of your clients are CPU. So now you've
yeah,
added a huge amount of cost, right? And so this is what they're dealing with. So the BC2 AI is a solution meant to help with this transition, which is you can install it at a similar cost to the UPS only and have at least some limited amount of pulsing in case you have that challenge as you start to get your clients. So it was really meant to be this bridge type system.
Hmm.
And then in the background, as I described, we're moving more and more to that pulse load where we can handle higher and higher pulses and also develop service programs so we can change those batteries out more readily. And you can imagine back to sustainability, if you're changing the batteries out more frequently, you want to make sure you are recycling all of those in a sustainable manner, which we have that capability. So it really fits our model for this sort of consumable AI type battery where you make it very modular so they can be changed out quickly, and then we recycle them and we can reuse the electronics. So it's a great challenge for us. But
yeah.
yeah, the transition is what we're looking at right now. So our competitors and other companies, we're all trying to put some band-aids on this AI dynamic load right now. And it's working. We like a lot of technology businesses, we'll keep it moving forward, right?
Yeah.
But in the background, many companies are shooting at this sort of future roadmap as well.
Safety remains a key concern in large-scale data center deployments, particularly as lithium-ion systems have raised questions about thermal runaway risk. How does nickel-zinc chemistry then address these safety challenges while still delivering high power performance?
Yeah, well, again, you start again with this power of good chemistry. So our chemistry, we don't have flammable materials in the battery. So we use nickel, zinc, copper, and we use an aqueous or water-based electrolyte. And that's where lithium, has the issue, which is, they use a flammable electrolyte. And again, I will say it's a bit of a feature. That's where all their high performance comes from. So it's sort of like the base of your technology is where the performance comes from. So lithium systems have become extremely reliable and much safer as the years have gone on, right? The using of their BMS and other kinds of technologies make them safe and usable in many applications. So lithium's okay, but
Yeah.
I always look at innate risk. So basically the idea is if you install 500 megawatts of batteries in a data center,
Mm.
and you have the choice of making that flammable or non-flammable, you're always going to choose non-flammable. Lithium addresses it through sort of their design and their BMS systems to make it a very safe system. So both can be used, and they are being used broadly across the world. I think we have an advantage is when you start looking at regulatory, firefighting, fire suppression,
Yeah.
how fast and broad and big and long a fire could be. The potential just isn't there with us. We have the energy in the battery, and once the energy dissipates, you really just have a block of metals, so they're not going
Yeah.
to on fire. So it's the probability of risk times what happens when you have an event is sort of how people measure this. And we try not to be any, we don't want to slam our competition, but we really believe we have an innately safe battery, and it's very friendly to all the regulations that are coming out. We pass with flying colors. Our measurement of this is sort of, UL testing, which is the same for all batteries, and we really reach a gold standard there of what a battery should be.
Now, the Middle East is investing heavily in hyperscale infrastructure and national AI strategies. How do you see ZincFive's technology aligning with the region's priorities around resilience, safety, and sustainable power?
Yeah, I think it's a great match for us. Again, I mentioned at the very beginning and continuous improvement of our ability to support customers afar. It'd be our core concern. So we're a company now that has got to scale,
Yeah.
and we can enter that market with great support and confidence. And we are starting to get pulled in, via
Mm.
quotations and interest in our battery. And, we have global data center companies that use us other places that are going into the Middle East. So it's a great match. And I hope to really, aggressively, market and bring the product to that region. It's always nice when it's a little bit newer. We're always competing
Mm.
with the old dogs and and it's hard because it's a conservative industry. So we're hoping to make inroads with new customers there, and that the common sense and the regulatory and all the areas around sustainability and safety will help drive us to success there. So yeah, we're very excited to enter that market and to support customers in the region.
Finally, then, Todd, as AI infrastructure continues to scale globally, how do you see immediate power solutions and nickel zinc technology more broadly evolving to support the next generation of data centers?
Yeah, that's really the great question. So one of the key things that's happening because of this advent of the higher power density, not just dynamic loads, but just very high power dense systems, the industry is moving to higher voltage. So when you look at the large hyperscaler infrastructure, they generally operate at low voltage, or 48 volt would be
Yeah.
traditional, anywhere from 12 to 48 are the typical installs. The problem that's happening is with these high power dense systems, the current in those low voltage systems is very high, so they're having to deal with the thermal load. So the industry, through roadmaps that are published and investments being made, are moving to higher voltage. So 800,000, 1200 volt systems are even being considered. With that increase in voltage, you have a better budget for current. and temperature management. So, and it's necessary. So you see this transition, as I told you earlier, Bill, the shift
Yeah.
to new technology, new architect, everything's changing. So you have the ability to get the energy to the site. We see lots of articles about is there enough energy and power out there, for AI data center. But once you get inside the data center, we're talking about distributing 800 plus volt throughout the data center. That's never been done.
Yeah.
And so there's a lot of challenges there. And then you have the getting the power to a very concentrated area of the data center where you're talking about GPU clusters, very high power, and then safely, sustainably, and otherwise managing all of that. And we think that the immediate power side of it, whether we're close to the GPU servers helping to absorb the dynamic loads, or we're there to back up the data center, or even deployed. We've had recent inquiries outside the data center where large new style energy systems are being built to bring the power to the data center. Things like load adjustment or
Yeah.
load leveling, or there's a lot of dynamic loads throughout this system. So we think that large scale nickel zinc batteries can be part of the solution. So we're very excited about that.
Right. Thank you very much, Todd.
Thank you, Bill.